My name is Brooks Patrick. I'm an account executive at Esri, working a lot with 3D and CityEngine. I'm joined here today with Eric Whitner, also a colleague of mine, the product manager of CityEngine. And we brought along two special guests, Devin Levine from Levine Associates. He's going to be talking a little bit about CityEngine in private practice. And we also have Eric Brady, coming to us from Rochester, New York, Bergman Associates, talking a little bit about extending ArcGIS Pro with CityEngine. So what we'll do is I'll give you a quick introduction to CityEngine. We'll hand it over to Devin, who will give you a quick overview of CityEngine in private practice, how they're using CityEngine to support their design process. Then I'll take it and I'll actually give you an overview of CityEngine within the whole entire platform, really where it fits, where we're going with it. Then I'll hand it over to Eric. Eric is going to take you through ArcGIS Pro integration with CityEngine, a great project in Cape Cod, the Cape Cod Commission. And then Eric Whitner will actually take you on what's new in CityEngine 2016 and the road ahead, along with a demonstration, a live demo of 2016. And then we'll open it up for Q&A. So just to get the housekeeping out of the way, I have an envelope. If anyone wants a copy of the slide deck, along with some links that we'll be showing today, I'll just let that go around the room just for convenience purposes. All right, so just a quick introduction to CityEngine before I turn it over. I always like to start off with Hollywood. So who here has seen Big Hero 6? It's called Baymax in Europe. Okay, about half the room. So we see CityEngine being used extensively in Hollywood in motion graphics like you see here. When it came to San Francisco, they did not model that by hand. They used a procedural engine, right? So when it comes to CityEngine, it's all about efficiency in 3D modeling. It's being able to create entire cityscapes in a combination of styles like you see here with a cross between Tokyo and San Francisco. Independence Day 2, I know it came out on Thursday. They're actually using CityEngine extensively as well, so when you see the Burj Khalifa coming down into London, you can tell all your friends that was GIS software. We're also used extensively in the defense and intel area. This is a visualization from Thales, a French defense contracting firm. They make training simulations. This is actually a procedurally generated city in Norway. So we can start to take two-dimensional GIS data and stand up pretty high-resolution city models pretty quickly. And CityEngine is also being extensively used in planning and design. That's really its core focus area. And that's where our guests will be able to elaborate further on. This is a city in Sweden, the second largest city, Gothenburg, Sweden. This was the work of one individual at the city. And he was able to get to that level of definition in the buildings and in the layout because of using a software like CityEngine, where procedural modeling is really boosting the efficiency. What they're doing is they're designing entire neighborhoods at this level of detail to really give the public a sense of scale. And when it comes to public infrastructure, such as the new metro lines that are going through these neighborhoods as they're being redeveloped, a lot of Sweden, if you aren't familiar, they have a lot of harbors that are now not used as much. So along their waterway, they're doing major redevelopment of their harbor areas. This is a nice example from Devin's firm, really just showing why people are using CityEngine. What you're able to do is apply a rule to a footprint, for example, a 2D GIS data set. And what you can do is quickly manipulate the 3D model with handles. This is called the inspector on the right. And we'll go into detail a little bit later with the live demo. But just to give you a sense of the speed, while this is sped up quite a bit, you can see that just by changing a couple of these parameters, we can quickly manipulate the 3D model. So our group here at Esri, we're working predominantly within local government planning and private practice. So we are pushing CityEngine for long-range planning when it comes to comprehensive planning or strategic master planning, looking at zoning, conceptual zoning volumes, and development potential. When it comes to current planning, it's urban design, being able to very quickly create these high-definition mock-ups And of course, it supports decision maker communication when it comes to design review in front of the planning board, giving the mayor some city model to actually talk to and go into all the capital planning projects around the city. And a large portion of that decision maker communication component is web scenes. You might have seen a lot of that during the plenary. Web scenes are sort of the output of CityEngine, where in the past 3D was output to video or static imagery. Web scenes are really the new format. So these web scenes and making them 3D, it really supports clear communication to these stakeholder groups. So CityEngine is a focused app for planners and urban designers, and it's being able to allow them to leverage the professional GIS folks in the city who maintain the data that's needed to fuel CityEngine and create that base map. CityEngine supports the communication to all the stakeholder groups, whether it's internal or external. We've seen three major patterns of using 3D GIS for planning. Apart from just the engagement part, which I think is pretty clear at this point, we see the 3D city models being maintained with these rules, really data-driven, and the ability to overlay analytics. Planning, be able to explore, design, and evaluate plans in the context of the real environment in 3D. And so this is not just desktop. With CityEngine, it is a desktop software, and it allows you to very quickly create your city models and conduct planning exercises on them. When it comes to engagement, that's where we see web and even mobile now come into play. And CityEngine exports directly to this new 3D feature service that we've seen during the plenary, directly to ArcGIS Online. Some use cases, just to show you what we're focusing on. It's really not only the 3D city itself and the overlays that you can do with it, but also targeted approaches to comprehensive planning and zoning and master planning. And of course, storytelling, being able to take these web scenes into story maps and tell the story of developments taking place. We've recognized a converging professional and consumer expectation. How many people in here, I know a lot of you guys are Esri folks, but how many have taken a tour in Google Earth, right? Probably all of us. So is everyone, outside of the local government internal back office sphere. All the public has probably found their house in Google or played a game like Gran Turismo, which is racing through the streets of some European city, or looking at, now we have companies like Euclidean with large point cloud data sets that are so dense in points that you can see down here in letter D example that you can't tell it from a regular 3D model. And we have CityEngine, which is a procedural engine, and it's really this converging between gaming and Hollywood and GIS that we see. So why do people use CityEngine? It saves time and obviously costs with time. It's a rule-based generation of 3D geometry, so with SketchUp or Revit or Rhino or any traditional 3D program that I'm sure some of you guys are using, it's equal input, or equal output rather, for equal input. So if I spend 5 hours modeling a city, I'm going to just model that particular part of the city. And if I want to make a bigger city, it's going to take that exact amount of time. Double, right? So with Esri procedural 3D, what we can do is write a rule up front that allows us to very quickly scale, as well as perform redlining exercises, change orders on that model fairly quickly with the use of these handles on the side. So it saves time in the long run. So we can create base maps, integrating streets like you see here with rules. We can overlay our point data, give it a rule in CityEngine, make our trees, and bring in even photogrammetric buildings that might come from a partner like Pictometry. Once we have our base map, they come in many different resolutions. We can start to make traditional 2D GIS layers three-dimensional using rules such as max heights, setbacks, stepbacks when it comes to zoning. We can also start to do urban planning and urban design when it comes to understanding the mass as it relates to the land use in the buildings and the reports such as the generated population or jobs potential for these new designs. And this is actually downtown Redlands where Esri is located. The real game changer is the web, being able to take that entire city, put it out on the web, and actually conduct design review completely within the browser, being able to email that link to a stakeholder or an internal employee for that review process. So I'm not going to spend too much time. I'm going to hand it over to Devin Levine. He's going to actually take you through a lot of what they've been doing in private practice. I'll hand it over to you.
All right, thanks, Brooks. So what I want to do, I presented at the Geodesign Conference in January, and then I think for Directions Magazine in November, and I talked about our move into CityEngine and how our firm has sort of started to embrace it. So I know those presentations are online. What I want to do is kind of jump in and show you how we're using CityEngine today and how it's kind of saving us time and money as a private practitioner. I own a co-owner of a planning firm based in Chicago. We have a national practice. We're all over the country, and we specialize in community planning, urban design, and economic development. In 2014, we won a pretty prestigious national planning award as a firm in the country that was shaping the profession. And in giving us the award, the American Planning Association recognized how we are using technology and how our plans are becoming more graphic. We created a piece of software we call SMAP or SMAP. It's community outreach software. It was based on Google Maps. We just ported it over to Esri, so it's downstairs at the exhibit hall. But one of the things that I think we've done a real good job of is embracing technology. I've been using SketchUp back from when they were at Last. Then I went to Google, and Google had this SketchUp Pro program, and I was designated as one of the SketchUp Pros that went around the country to schools teaching people how to use SketchUp. Even now with Trimble, we've had a great relationship with them. They were in our office last year filming us work. And the reason we use SketchUp and Adobe Illustrator and GIS, we like to make rich plans. One of the things we've been kind of promoting as a firm for many years is that plans have changed. We see a lot of planning documents in City Hall that are just hundreds of pages of black and white text, a couple of crummy maps. And nothing sort of drives me more crazy when I see a website like this or a plan like this where you have the text only, and then you have all the different figures, and so they couldn't even package the plan correctly, and so it's sort of a little do-it-yourself craft. You got to print out the plan and print out the maps and assemble it yourself. And there's still a lot of communities doing this, and when you start to look at what these plans look like, I mean, you print it and you see, these small little photos. Really, that construction photo could be anywhere, and then there's an insert map. And one of the things we do a great job of is integrating the maps and the text. And even now we're kind of, I think, leading the charge in our planning profession using story maps. As we prepare a plan, we then kind of come back in and we're starting to dive into story maps. And I have an example of this if we get into the Q&A if you want to see it. When we boil down our plans, we have really these components. We have some introductory text. We have a map. And these are pages right out of a plan that we did for the city of Flint. We have our annotated legend where we integrate the legend into the maps, so it's not our recommendations are sort of it's one piece of paper that kind of tells the whole story. And then on the right we have just a simple base map where we're looking to drop our plan symbols, so those symbols really pop off the page. And then in the other pages where there aren't maps, we have photos, we do development visualization, some precedent photos, site plans, vignettes, and inset maps. And this is where we're seeing CityEngine come into our plan documents. And one of the things I'll walk you through here now is what we've been doing for the city of Tulsa. We've been hired to do a bunch of neighborhood plans for an area north of downtown. And CityEngine has helped us take these recommendations and help visualize them. And so when we come up with a recommendation that we need to put more trees into the neighborhood, this sort of brings that document to life. I mean, that's a pretty self-explanatory recommendation, but to be able to use CityEngine and to write some CGA code that kind of takes an existing neighborhood and puts more vegetation in. And so those are SketchUp houses that we've dropped in with the CGA rule, but this is 100% CityEngine output. The complete streets rule that is made available by Esri is where the streets are coming from. And then a policy like this where there's a lot of vacancy and a lot of dilapidated housing in this neighborhood. And so encouraging people to acquire the vacant lot next to them and expand their side yard for either a garden, recreation, or just open space. A sound barrier. There's highways surrounding all 4 sides of this neighborhood without any type of sound walls. And so just using some simple rules, we helped kind of visualize what that would look like. And some of those earlier presentations I mentioned, I do a whole walkthrough about how this scene was created. And then a simple cross-section, complete streets, big movement across the country. There's a complete streets rule package. You can create drawings like this very easily. Just Brooks showed you that slider. You drop right in and you can create these street cross-sections. One of the key sites in this Tulsa, you can see just north of downtown, pretty big piece of vacant property. And it's been bought up by OSU Tulsa. And so the university has been sitting on this property, and the neighborhood's trying to reinvest in itself, but there's still this sort of void. And we talked to the university, and they didn't know what they wanted to do with it. They kind of looked to us for some guidance. And so we developed this model. And so this is CityEngine output, and I'll walk you through kind of how we got there. And this is where I think it comes into the private practice. So if you're going to dive into this, we set up a Git, which is basically we got to treat this like a coding environment. CGA scripts can be very technical, and when you start to see sort of all these rules, just to jump in and start editing them, you don't want to sort of break something that's further up in your code. And so if you're not familiar with Git, it's basically a version control system for code. And we use something called Bitbucket. It's free, and it allows us to keep these CGA scripts. So if we make changes, we can see what's happening. And so just walking through this Tulsa example, these are the building footprints of that site, and that we needed to kind of create these buildings for this campus. So when we take a look at these buildings, these are the existing OSU buildings. They got these copper roofs, and just the articulation of the roof is kind of set back a little differently. And the rule I had programmed, and Brooks sort of showed you in that video, those sliders where we can generate those 3D buildings. I'd written some code that kind of set back buildings at different parts, whether it was set back from the street or waterfall, but I didn't have anything that kind of recursive or like a wedding cake. And so we had to kind of write that code for this. And so we jump into CityEngine and we write that CGA, and we want to keep track. So I don't want to, all of a sudden, I write this and something else doesn't work. So this is a screenshot inside of SourceTree, which helps us keep track of our code. And you can see in the bottom right, all the green is the code that was added. So visually, I can sort of comb through here and I can see what I've changed. And then you push it up to a server, and now, so then my employees or my coworkers can go grab that new code. And so rather than storing it on a server where we're constantly overwriting it, this sort of helps us keep these versions in the cloud. And then so we pull that down and we can generate this. And so this is where we ended up with those buildings for the university. And then once we styled them, CityEngine allows you to store styles. So then we push that style up. So if we ever need this type of building again, we can grab it just from picking it up. And then you can see inside the source tree here, the little notes. Keep track of your version. So if you want to know what was different, and you can always roll back to a different version. So here we're just saying we added the style for the university buildings. The update before that was the recursive setbacks. So a real good way of keeping track. The other thing we did is we were able to extrude these office buildings, but they didn't look modern enough. So we wrote a little rule that kind of twists the floors a little. So give it a little sort of, I think, more modern feel. And again, we're pushing everything up into Git. The last thing we kind of noticed as we went through here, and this is where we kind of see the key to drawing is seeing. We start to look at, to make something look realistic. There's one thing that we look at this, that when we saw our sort of scene that didn't quite look right, and it was the absence of the rooftop mechanical. When you see a bird's eye view of an aerial photograph, all the air conditioners and everything on top of the roof, and it just kind of adds a level of texture to the top of a drawing. And so then we wrote a rule that basically scatters these air conditioners on top of it. We're just inserting a cube. We actually have a density slider, so if we want to increase the number of AC units. So a small, minute detail, but when you see the final rendering, really kind of pulls off the final appearance. The process we go through is still sort of the same. And so in this example, we got hired to help visualize the potential of this vacant site. We still use pen and paper. We sketch out the site. We try to see what is the potential. There's 6 different options. 3 were tearing out that old industrial building, and the other 3 were reusing it. It was bought by a mega church. They've turned this into a place to pray and get your oil changed all at the same time. And so we did the development around it. And so we pitched the client these 3 concepts. We use SketchUp at this point. This is still early in our use of CityEngine. We did some simple massing. Then we took those footprints from SketchUp, we brought them into CityEngine. And if you've ever used SketchUp, trying to put windows on a curved surface, almost impossible. CityEngine did that for us automatically. And so those are SketchUp windows that we're placing in CityEngine on those curved walls. So now what we're free to do is really design any type of shape we want to do, and CityEngine will handle the completion of the 3D model. So here it is in the final render that we gave to the client. And the benefit of this procedural modeling is how quickly we can do these. So we didn't just deliver them 1 3D drawing, we actually gave them 2. And something I don't think we could have done before CityEngine. The last thing I'll leave you with, this is a couple weeks ago, we had a client reach out to us. There was a site in their downtown. They wanted an interactive 3D model. And they wanted to assist the property owner, a church, in how to get rid of the property. And the church was worried about views to their cathedral. So 2.5 acres, we sort of quoted this at about $3,000 to $5,000, take about a week or 2. So here I'll start the clock for you. And this is the consulting part of me that I don't like, is the fact that I got to keep track of how long stuff takes. But this is a good story from a business owner perspective. So this is CityEngine 2016. Start the clock. I get the map data. 3 minutes in, I'm configuring, finding that site inside of CityEngine, identifying the extraction rectangle, configuring the OpenStreetMap data that I need. 10 minutes in, I've got the aerial photograph, the street grid, I've cleaned it up. 12 minutes, I'm importing the GIS data. We had building footprints already supplied by the city, parcel data. It's all geo-referenced, drops right into the exact location we need it. Couple minutes later, I'm writing just a quick code to extrude these buildings, put in some parapets, reusing my air conditioning code to put that rooftop mechanical on those buildings. Find all the adjacent residential. Again, another quick rule, I'm just randomizing the type of roof, whether it's a shed roof, a gable roof, a pyramid roof. Some sort of stock rules right out of CityEngine to give kind of that texture to the context of the scene. The church, sort of that primary piece of property that was in question, we had already as a SketchUp model. So we dropped that in as an existing model, as a collada file, so 20 minutes. And then here I am at 25 minutes, I'm doing the development scenarios for those different buildings. So here's a mixed-use, multi-story building with that detailed building generator code that we had. So that was one option. 5 minutes later, we have a second concept where we're tearing it back. And 40 minutes later, we have our web scene. So from a profitability standpoint, 40 minutes is pretty good for $3,000 to $5,000 worth of work. We still want to get in here and tweak it, add some trees, but boy, something that easily, if we had tried to undertake this with SketchUp, we probably would have lost money as a firm. But it was an existing client we had to keep happy. So definitely a tool that we love. And if you're a private practitioner and you're wondering, am I ever going to have to use this? This is an RFP that we received in the mail from a city just last week. And you look at that requirement, the visualization, the city is seeking a plan that is highly visual and web-based. The final product shall include both a detailed summary of the plan and process, but also an abbreviated version to convey to the public. Detailed representations in HTML5, Flash, or clickable means would be well received. And so the public sector, you guys are looking for this. You know it's out there. And if you're in the private practice, I think you need to start getting on board with these tools, or you're going to be sort of left behind. So with that, I'll pass it over to Brooks.
Thank you very much, Devin. And just to mention, Devin's also downstairs, booth right next to Drone Zone, I think, as well. If any other questions, go his way. Great. So I just want to give you a quick overview of CityEngine within the ArcGIS platform, and then I'll hand it over to Eric Brady to talk more about CityEngine inside of ArcGIS Pro. Where CityEngine sits within the ArcGIS platform, I know this graphic might seem familiar to a lot of you guys. What we do is we support the planning and urban design process not only in the rapid creation of 3D scenarios like you've seen from Devin and the evaluation, but we also can take those outputs from CityEngine or even ArcGIS Pro or GeoPlanner or other tools for planning and output those through web scenes, which can be created and then brought into Story Maps and Web App Builder, both of which have 3D capability. And I should mention the new Story Map Cascade template is really nice for 3D as well. I just tried it last week myself. We also have ArcGIS JavaScript API and Runtime SDK that handle those same 3D feature layers on the web. So it's not only authoring, but also serving out and engaging. And so CityEngine is really to empower the planner or designer when it comes to iterative design in 3D. And to support the process of the evaluation process, rather, of multiple proposals. Being able to very quickly create multiple scenarios and have that side-by-side comparison that's possible in web scenes. We can also start to look at building web applications that take these web scenes and allow you to showcase strategic plans, development alternatives, and really initiate that citizen dialogue at a community meeting. And really have them take that link home and share it with their friends, really promoting that not only within the public engagement sphere, but also at the planning board or even with the mayor's office, giving them, say, the ammunition that they need to get these major projects through the pipeline. Or not, rather. And so we can actually take those comments back and start to enrich the process because as you've seen, CityEngine really empowers what we like to call the back office capability, being able to plan and design iteratively, and then even further supports the front office in doing so with that engagement. So 3 strategies to take away today when it comes to using CityEngine, like you've just seen a great example of. Discover patterns with 3D. How do you use 3D? Do you need a building rule to create the context? Do you need one building rule to do your proposals? Discover these patterns. Have your group of rules in CityEngine that you can always deploy. Second, work more efficiently. Start to, I guess, not use highly manual software all the time, but start to use procedural for these more iterative techniques. And finally, streamline deliverables. Try out these new web scenes and see how your clients like them. So CityEngine is also extensible, is that the right word, extensible in ArcGIS Pro. We can start to take these rules, which is written in CGA, it's a scripting language within CityEngine. That CGA code is a combination of code and the 3D models and the textures that go with it so that the code knows to put brick on the walls and to put little air conditioners on the roof and that sort of thing. So we can start to package up that rule as rule packages. That allows us to take the rule created in CityEngine, create a lot of rule packages that can be hosted in ArcGIS Online and used within ArcScene, ArcGIS Pro, or even Unity or Autodesk Maya if there are some people in here that are using those tools because we support the game industry and film industry highly. When it comes to ArcGIS Pro and its integration of RPKs, however, to show you just how that's done and show you some real-life projects utilizing that kind of technology, I'm going to hand it over to Eric Brady to tell you more.
Thanks, Brooks. Good morning, everyone. Okay. So Bergman Associates, we're an architecture, engineering, and planning firm. And for years, we've been delivering our plans as 3D interactive scenes that you see here. And I think everybody can understand the value that these offer. It really helps a community understand what that plan will look like. But as Devin has talked about and Brooks, these are all hand modeled and it takes a lot of time to develop these, and as plans are created there's a lot of iteration and redo. So it's not necessarily cost effective to build out significant 3D scenes. So when CityEngine came around, we found it to be an excellent tool to help develop these plans. This is a web scene that was exported from CityEngine, a master plan update for the city of Rochester that we worked on. And what we did was we superimposed the master plan within this 3D base map that was fairly exacting of the existing conditions within the city, really helping people to understand the place and the community they were living in. But then we were able to use these parametric rules that we've been talking about, using the CGA script within CityEngine to create these representative infill buildings. And the whole purpose was to talk about the form-based zoning code in a way that the community could really understand in terms of the size and density of buildings, talking about the types of material facades, window coverage, to really articulate how that plan might be developed. But also this 3D base map offers more value to the planning department. We use it a lot for site plan review. So this is a bus station that was designed and ultimately built, and we were able to bring that BIM model into CityEngine and then lay it inside this base map and then share it out as a web scene to help stakeholders and policymakers really understand what it looks like in the context of the whole community and to share it out with the public. So CityEngine really proved itself right away to be a powerful tool for us as we develop these 3D plans. But we're also really interested in data. So while those are great visualizations, we really want to also create 3D base maps that have information behind them that can support analysis. And here Esri has been really a great help, helping to develop a database schema within the geodatabase, which really comes down to creating a lot of relationship classes that are all tied to a building footprint. So you'll have real property data or tax data and tables. You have all your rich vector data you're using already. And then you may also have many different models, from simple massings to very textured, detailed buildings. And all of this data can be built and created within one geodatabase and then used in your 3D base map. So a few years ago, we moved forward with this type of 3D plan with the city of Charlotte. And so here you can see these models are color-coded based on an attribute behind them. So while they're a visualization, really they're data, they're GIS data, and we have rich attributes assigned to each building. And then we're throwing some traditional vector data underneath. So the 3D base map now really becomes an analytic platform for symbology to understand and link data, right? Because we have attributes here, we can jump to the real property data. So it really, again, proved to us and showed that the 3D base map, using Esri technology, we could bring data and visualization together. So while we have great visualization, we've got our geodatabase information, we wanted to then look at functionality, really building a 3D tool set. So we're in the middle of a project right now, pretty ambitious and aggressive, with Cape Cod, the Cape Cod Commission in Massachusetts. And the goal of this project is to create a 3D framework and tool set to support ongoing planning with a real emphasis on water quality. So for the deliverables here, we're creating a 3D base map of the entire Cape. That's over 260,000 structures. Most of these are built with CityEngine, though we do have a partner, PLW, who's also a partner of Pictometry. These are third-party models that we can purchase. We're adding lots of rich attribution using that 3D planning information model. And as part of that, we're assigning impacts, baseline impacts for each building. So every building has parking and traffic and wastewater impacts, jobs, population. So using basic planning formulas, we assigned these impacts to every structure based on square footage and the use of the buildings. And then also we created some zoning envelopes to show where the buildings could be located on a parcel. And then we implemented a tool that we've developed called Impact 3D. So it's a little bit of a choppy movie, but here's a subsegment of some of those models. And you can start to see them appear here on the base map. And really, these are all parametrically derived from CityEngine. We took the building footprint that the commission had from their planimetric data. We knew the elevation of each building from LiDAR, and then we just used some rules. A lot of them came as sample rules from Esri, and we were able to model these out as representative houses, right? The real house doesn't look like that, but it conveys to the community what's there. And then as part of the base map, we also have some of these PLW models, right? So you can see the architectural detail here relative to some of those more generic houses. And then here's just, again, one of our parametric buildings with that traditional cape roof. And what's important to us, again, is this data behind it. So while it's a great visualization, we have lots of data to support the project as well as ongoing analysis needs. So zoning envelopes was one of the deliverables. And here CityEngine, again, proved to be a great tool. So we really reused a tool and some code, CGA code. We compiled one of those rule packages, an RPK file. And here in ArcPro, we're setting the symbology of a 2D polygon feature class that has the attributes of setback, front, side, back. And we're just mapping the properties of the rule package to the attributes in each footprint. So using, here you can see we're just mapping to the columns. And we're then able to just use ArcPro to then generate these massings. And they're kind of hard to see. I should have set the transparency a little better. But we now have these basic block representations of where a building can be placed within and on the parcel. And so this was CityEngine code that we brought in, and now we're using ArcPro to symbolize. Here are some of those models, again, and we can zoom in and just look a little closer at how they fit within those zoning envelopes. So for existing buildings, they're already there, but this is really, these zoning envelopes really support new development and helping the community understand the zoning code and height allowances and setbacks, etc. But to get there, we had to use CityEngine again. So the whole key to having setbacks is knowing the front of the parcel. So what we were able to do is use another CityEngine tool. We had a line feature class, a polyline, we knew the front of each parcel. And so we brought that in, and we just used the compute front edge tool that comes in CityEngine to assign the index of every polygon. So up in the top right, you'll see in a minute here the index. Basically every vertex or vertice has an index starting at 0 to whatever. And we need to make sure the front is set to 0, the starting line, and then it goes counterclockwise. So that was a great tool. So CityEngine really was a key to building this data. And so Impact 3D, Bergman Impact 3D is the tool we've developed. It's an ArcPro add-in, and it's really meant to support dynamic visualization and dynamic scenario planning within the 3D base map. We can texture those models dynamically. Those are both driven from CityEngine rules. But we also have impacts that we can calculate dynamically to understand how those buildings perform. And it's very configurable. So here in this movie, this is a basic scenario where we've got a parcel that's primed for development, and the planning office wants to understand, what would be the impacts if we built on this property. So here we have that setback cube, and then what we'll do is we're going to open up our Impact 3D panel, and the starting point is to first digitize a footprint of a potential building. So we're going to want to make sure we're inside that setback, and then we call it just a stub building here. But now we're going to use the tool to assign properties, and we're really writing to a rule package. And so we're going to set the height and some texturing parameters, and quickly have that 3D mass generate inside the base map. And this is that classic visualization use case, right? What would a building look like on this parcel that met the basic parameters of the zoning code? And we've got different texturing styles, but this is meant to just be kind of a conceptual type building. And so that's great, but really we also want to understand what will the impacts be. So here we can come in and we can assign how the space will be used from a variety of different space use types. So in this scenario, we'll call it mixed use, will be hotel and restaurant. And as we select and assign the percent of space, we can see below the impacts, square footage and floor area ratio, what parking is allowed or available. And then we have impacts to parking and traffic, wastewater, jobs. And you can see the parking and traffic are quite high on this, based on this use case. So that quickly gives us a sense of, okay, if that was the type of building, how would that perform? And you may ask, well, how do you get those values? Well, these are variables that are well understood within the planning community based on space use and square footage. So we have a lookup table where users can come in, and it's highly configurable. We can add a new type. So here we're going to have a space type of transit-oriented development restaurant, or maybe a downtown restaurant where we don't expect a lot of cars. We expect people to be walking or taking the light rail, whatever it may be. And users can come in and assign these values. And then we're going to come back out to our tool. We'll change that type from restaurant to our new TOD restaurant TOD, and assign it to the remaining space. And then we can quickly see new impacts, right? So this is a great iterative tool for the planning office to understand what will the community impacts be, because traffic and parking and wastewater, that's a huge concern for planners. You don't want to flood your streets with cars. You don't want to overwhelm your community, your infrastructure. So here we have that, in that scenario, we have one building and what its impacts will be, but we also want to understand relative to the other neighborhood or the surrounding buildings. So here the second panel is the reporting page, and we can look at those impacts relative to the baseline. So you remember we calculated baseline impacts to every structure in this model, so we were able to see. And here now is a planning scenario where maybe we're looking at the whole corridor. And all of these little orange buildings, if you can see, are all of these scenario buildings. They've been modeled out, they've been assigned their space use, they have their impacts. And just using ArcPro and a basic selection, we can select everything to understand what those impacts will be relative to the existing conditions and to the proposed. And color is existing and gray is proposed. And we can have many different types of attributes. People have talked about dogs for dog parks or bicycles or really whatever supporting whatever plan you may have or what needs you need to analyze. And then the tool can support various geographies. So we're selecting here just on the map, but more realistically you would select a watershed or a jurisdictional boundary to understand what proposed development impacts might be in that specific geography. And then another great tool within ArcPro, and CityEngine of course supports this, is the idea of bringing in third-party models. So plans are great, but you really want to develop that parcel in the end. So once a developer is ready to build, CityEngine and ArcPro are very effective and support pulling in a collada file in this instance. So this is a developer's model right from SketchUp, and this is the building they want to build. We can bring it into the base map. We can evaluate it visually. We can test it against those setback criteria. Maybe they'll need a variance for that taller portion of the building. We assign the same build-out impacts based on the space use, and now that building, once it's created and ultimately built, becomes part of the base map. So in summary, we see 3D planning really growing. I think we're at a tipping point with Esri technology, with interest out there in the community and within the planning offices, where these 3D plans, as Devin talked about, are really becoming the way of doing this work. We can do these dynamic visualizations. We can use all these parametric textures to symbolize and create buildings. And then we can add all that great GIS data that we love. And the great advantage, of course, is you're not delivering, planning firms are now no longer delivering that compiled plan, but it's really a living document. We're handing over an interactive 3D base map. The plan is placed within it, but it really is an ongoing living document. And it supports all of your GIS data. ArcPro is a desktop user-focused tool set, so planning office GIS skill sets can support it. And the great web publishing that we're not showing here yet, but being able to share that all out in story maps and web scenes is a very effective way of communicating those plans. Thanks.
Thank you, Eric. So my name is Eric Winner. I'm the product manager for CityEngine. I wanted to talk a little bit about the road ahead and actually show you CityEngine 2016, which just came out this last week. So we've seen CityEngine live, and we've seen examples of ArcGIS Pro live. You're probably asking yourself, when should I use these two different products? They're both capable of doing procedural modeling. They both have procedural engines in them. So CityEngine is really focused on interactive design. So it supports a bunch of functionality that actually doesn't exist in Pro yet, such as interactive handles. So some of the parameters you saw them changing, you can expose them as a graphic control, grab that, manipulate the building on screen interactively. It also does dynamic reporting. So the kind of dashboards that Eric was showing, we can generate metrics and actually generate dashboards in CityEngine. In Pro right now, you have to push it through the geoprocessing tools to get that processing done to see the metrics. But all these things are kind of over the long term, we're looking to bring these two products close together. CityEngine is the place where you author rules, and it's the only place where you can author rules right now and then share them as rule packages, and they can be consumed in ArcGIS Pro. And then CityEngine has this whole capability called the graph. And the graph is about bringing in a network and based on attributes, generating streets, carriageways, sidewalks on the sides, and populating those with 3D features to make realistic streetscapes. That only exists in CityEngine. So we're going to continuously improve Pro and make Pro better, but CityEngine will also continue to improve and kind of stay out in front as a research and development tool as well as a design tool. They do support some slightly different data types. So LiDAR is a good example. Importing LiDAR, last files, last data set, visualizing LiDAR, classifying LiDAR. That's all going to be done in ArcGIS Pro. We don't really have any plans to bring that into CityEngine, although in the long term we may look at consuming things like LiDAR services eventually in CityEngine as the ability to help use that as context. Building information modeling is a hot topic, and it's supported in Pro and CityEngine, but kind of in different ways. You can take a BIM model, you can slim it down to its shell, so to speak, so you get an attractive looking building, put it as a Collada model or an FBX, bring it into either one for visualization. But if you want to try and capture the hierarchy, the complex relationship between all the parts of a building that's in a BIM, typically you do that in ArcGIS Pro through interoperability, reestablish all the relationship classes, saying the window belongs to the wall belongs to the room belongs to the floor, etc., to kind of rebuild that relationship. So Pro's a little more advanced there. Multi-patch editing. So raise your hand if you know what a multi-patch is. That's actually a pretty good number. So multi-patch is the internal 3D format inside ArcGIS, inside the geodatabase. It's basically just a 3D modeling format. We consume it. We can create it by external 3D models. We can create it procedurally using geoprocessing tools or like Layer 3D feature class. But Pro actually doesn't edit multi-patches. You can't reach in and touch a wall and change a texture or change a shape or move a vertice. Only CityEngine does that kind of level of editing, and in CityEngine it does it on what's called shapes. So that's a big differentiator. And then 3D export, ArcGIS Pro does a little in terms of being able to like push multi-patch out to Collada, but really CityEngine's a king, especially when it comes to the high-end visualization formats, like if you want to get it out to a Limbic and push it into a high-end renderer to create really, really gorgeous graphics. That's really going to be where you do it, is in CityEngine. In terms of visualization capabilities, you know, ArcGIS Pro is building a big graphics cache in the background. It can handle huge amounts of data from global all the way down to the local. So you can go all the way down in building. We've got a lot of examples now in facilities management. CityEngine is really focused on that city scale and down. The ArcGIS Pro, right, has this streaming and adaptive system where CityEngine's all in memory. So how much you can put in a CityEngine scene is really based on your extent and the level of detail of the data that you have. Animation, ArcGIS Pro has an animation framework. If you haven't tried it, try it. It's awesome. If you've ever used ArcScene and ArcGlobe, you're just going to want to slap the developers who built the animation framework in there because it's so much better than it used to be. It's really a joy. And then CityEngine is also, we're doing some research and development and exploring augmented reality and virtual reality, being able to take CityEngine scenes and pick areas of interest and export basically little immersive pieces that you can then serve out and share on mobile devices so that someone can kind of page through your city and say, okay, what does it look like here, and then see it with a device. So that's going to be something that we're exploring in the next release. So let's actually sit down and take a look at CityEngine 2016. I'll just do a brief demo. and then I'll actually talk us through what we saw. Can you flip me to 4? Okay, so this is CityEngine 2016. I want to build the city we're in right now, San Diego. So one of the new things that happened with 2016.0 is this integration into the platform. So I can go in, search for a location, San Diego. I'm going to zoom in. I can define an area of interest. Let me grab a section of downtown here. So I've defined an extent that I'm interested in. And what this interface is doing is it's actually pointing back to ArcGIS Online. It's pointing back to our list of base maps. So I want a satellite base map. It's porting to the World Elevation Service. And I can specify those and download those into my scene as the foundation of my scene. So now what we're trying to get around is this old workflow of, hey, if you want to use CityEngine, it's very simple. First, you launch ArcMap, you clip all your data to specific extents, then you import it in. And the catch with that was you had to have ArcMap to start with. Now you just go define your area of interest, and you get your base map instantaneously. It'll also reach out and touch, if you want to, OpenStreetMap. So you can select to import OpenStreetMap line segments, and it'll walk you through the process of aligning those to the terrain, cleaning them up so you can use them for street networks. And if OpenStreetMap has other data, you can select other data like building footprints. And some of the footprint data has height information, and that height information could be stored in a number of floors. It could be stored in a field called height, or bizarrely enough, it could be stored in a field called height1 or height_b. I've seen it in a variety of different ways because it's an open source data. But you can get footprints and then apply rules to those to generate 3D content. The other thing that this does, which I think is equally exciting, right, is I can actually now touch Portal and ArcGIS Online from within CityEngine and start importing my feature services that I've published there directly into CityEngine. So what I've done is I've searched for some San Diego data. There's a file here for footprints. Let's see. And it's not letting me. All right, Portal. Well, normally there's a button there for import, but I'm not seeing it. No, it won't let me drag. Figures. Once you do a demo live, I'm going to start with a fresh scene. Let's call it test. No. Okay. No. Okay. Get map. Okay. No, still doesn't let me import. Did you remove all my rights to this organization, Brooks?
Not my fault.
Yeah, unfortunately, I guess I can't show that. So you could bring in a building footprints and apply rules to it to create a scene, but the scene seems locked.
Shall I show it right here?
Yeah, go for it.
All right, sorry about the technical difficulties. It happens. At Esri, we like live demos, and that comes back to bite us sometimes. So like Eric was mentioning, what we can do is we can actually get map data. What I'll do first, though, is actually search for that same San Diego footprint here. In this case, we have footprints, and we'll just go import. What that does is that allows us to bring it directly into our scene. Actually, what I'll do first is give it a coordinate system based on San Diego. And it's not only just imagery. You also have the ability to bring in our topo base maps and many of our other base maps here as well. Both the terrain and the imagery can be different resolutions. It's really up to you. There's a slight slope to the downtown. You might see that here. Let's go ahead and download that. I'm actually using the Wi-Fi, so that actually might kill us here as well. I apologize. No, CityEngine will actually translate that projection on the fly. In this case, apologize.
I've almost caught up to you.
Oh, man.
It's a race. Oh.
All right, back over to you, Eric.
Okay, so I've got my get map data, I've got my building footprints, which I'll show you. The import function is there. I'm going to select these footprints, and then I'm going to apply a rule. So this is just a rule out of the Esri library that ships with CityEngine. Really simple, really straightforward. Generate, and this will take a second.
While you're doing that, what are some of the basic attributes you have?
So I would say the minimum attribute is some measure of height. So either a floor count or a total height. And then they have built into them a building type. So if you can do a crossover table and relate like a zoning category to a type, then you can drive specific styles of buildings based on what they are. And that's really the core foundation. And then Brooks mentioned LiDAR extraction. You could actually go in with the LiDAR for the footprint, detect and figure out what the style of the roof is. Is it a hip? Is it gable? Is it flat? Attach that as an attribute and use that to drive the creation of the buildings. Okay, so now I've got a collection of buildings in 3D. For San Diego. I want to look at redevelopment potential across this area. So I've got a redevelopment potential set of polygons imported from online. I'm going to grab the zoning rule. This is similar to what you were doing in terms of looking at zoning regulation. And I can generate, so these represent the proposed change and the maximum buildable area of specific parcels across the city of San Diego. So I can go in and actually manipulate these. So if I grab this one zoning volume, you'll notice I immediately get this interactive handle. Right? That handle is actually representing different kinds of controls inside the object themselves. So of course I can change parameters inside the inspector if I want to, but much more fun is actually being able to touch them on screen as kind of an interactive form. And there's setback controls for the different sides, all kind of dynamically edited inside this. The other thing that we mentioned, of course, was multi-patch editing. So I can create a shape. So I'm going to create a building form here. So this is just a simple mass of a building I want to create. I'll go back in, grab a different set of rules. I'm going to grab some mass texturizing rules. That creates a building mass, and then I can iteratively refine this and actually make a much more complex form for this building. Right, so it's not just extruding from the footprint up, but you can actually create masses and carve down to get to what you want. And then if you want to understand kind of what we've built here, all these zoning redevelopment volumes here have associated metrics with them in terms of the estimated amount of people that they're going to contain, the kind of jobs that they're going to contain, and those are exposed in reports. So if I select one of these, let's grab just one, right? You get this kind of table of different types of performance metrics. But that's not the most compelling way to look at the data. So we actually have this built-in graphing capability where we can graph across our whole design and understand the types of uses there, the number of hotels, the amount of industrial, the different use types, the capacity for jobs, the capacity for population, the total number of dwelling units, et cetera, that we're building in this proposed design. So once I've got my design, I actually want to share it. So I can select all the objects. And we had the old style CityEngine web scenes, which were kind of self-contained components. But now we have the ability to push up to a scene layer package, or an SPK, which is kind of a whole scene layer wrapped into one file. You can push that onto ArcGIS Online or on the portal, right-click on it, say Publish, and create a set of services. And those services can be used to make these dynamic web scenes. So I'm actually going to jump out to arcgis.com. Let's just quickly create a scene with the services from this San Diego. So I'm going to say new scene. Okay, I want to add some layers. Just like I did in CityEngine, I'll search my portal for S&DG. I'm going to add some existing buildings. I'm going to add the development potential. Let's add in a proposed design, and then let's see, let's do some analytics. So what we've done here just by adding in these services is very, very quickly create a little web scene of our proposed development, building maximums, and then we can also take those services or take the data that we produce from CityEngine and push it out, bring it back in ArcGIS Pro or into Core ArcGIS like catalog and do a spatial analysis. So in this case, we did solar radiation analysis to understand where the solar radiation was. Okay, so ArcGIS platform integration was the first new thing for CityEngine. The ability to pull in these base maps and elevation, consume them, and use them in CityEngine as your terrain and imagery. Being able to object layer publishing, so taking that scene layer package, the 3D content you created, produce a scene package, push the scene package up to ArcGIS Online or Portal, and produce 3D content that you can consume in the web. Feature layer support, so being able to pull a feature service of polygons in and be able to import those, use those as parcels of footprints. And then lastly, that whole interface where we can now search Portal, search ArcGIS on land, manage content, add content, etc., directly from CityEngine. There's a series of new functions within computer-generated architecture, CGA, the scripting language behind it. They're pretty cool. I'm just going to walk through a couple of them. Oh. Well, okay, let me just talk a little bit about them then. Area split allows you to take a designated area and cut it up either by a measure of area or a certain interval across different axes. So an example would be if I wanted to scatter AC units at regular intervals across a roof, I could say to give me 6 by 2, and it would scatter those automatically across. Or if I took a block, I could split a block into lots at a specified area and then scatter buildings inside that to create a block typology out of a rule. Inner rectangle is a new function. We had inner rect before. Inner rectangle is an advanced version of that. It does two things different. One is when you got the old inner rect, you got the inside rectangle, and that was it. Now you get the inside rectangle and the remainders, which is cool. So if I take a parcel and I say interact, I get a rectangle inside, I turn that in my building, and everything else I push through a park, and I turn that into a park or green space, so it looks like a nice little development. The other the thing that I absolutely worship about the new one is it also has a function that says, give me the largest rectangle that will fit inside this shape, whatever this shape is, which was like my dream function. Thank you, the head of the R&D center is right there, Pascal, so he gave me that one, so thank you so much. Primitives, so there's a series of primitives built in that CGA can use, spheres, cones, etc. So sometimes when you're trying to make a building, iterative splitting is really hard to make a certain type of shape. So an example would be in Malaysia, they were asking us how to procedurally make domes for mosques. And that was pretty challenging to do out of a square shape that you're starting with, which is a building footprint. So now I can just take a part of a sphere, put it on top, and use that as my dome. So extrude, roof, and insert extensions, those functions have been modified. And another really exciting one, especially for ArcGIS users, is clean up normals. So a lot of times you'll get a SketchUp model, and you'll import it in, and parts of it will be missing. That's because of backface culling. The faces are on the wrong side. So this is a new function that will try and automatically clean that up for you and make all the faces go on the outside. A lot of times people will draw in SketchUp on both sides of a wall. That's a double face, so it will try and clean up double-sided faces for you. So this is a really, really powerful cleanup function for preparing data for ArcGIS consumption and publishing on the web. And there's more. So Alembic is, I mentioned that it's a format for high-end rendering. So we can export to Alembic now. We upgraded to Python 2.7, and that means we support file geodatabase 1.4 when we export. The graphics pipeline was upgraded to OpenGL 4.1. We're working on a set of kind of new example rules that do other kinds of features like procedural furniture, walls, fences, that will come out in examples over time. And then we made some tweaks to the Collada export to support Collada import and export to better support Autodesk's Collada format. So they have their own dialect of Collada that isn't quite perfectly to the spec. So now we support that when you import it, so it'll look nice and clean. And we improved 3D KML import as well. Future direction, so we're looking at moving CityEngine towards more and more of an interactive design tool for city planners and architects. So that's interactive urban edits and analytics, individual edits on portions of buildings is something we're looking at and doing early next year. Adding in scenario management, so you can do multiple scenarios, switch between them quickly and effectively, and then do comparisons against them in the dashboarding technology. And then trying to build in some pre-packaged performance indicators that you can just attach to building rules and get metrics out of them out of the box. We're also working on a 3D content library. This is a joint project between ArcGIS Pro and CityEngine. So producing a series of 3D models for cars, people, helicopters, boats, trees, rocks, street signs, you name it, that we can wrap as a style file, deliver with ArcGIS Pro, so you can just call it as a style, and it'll come as a collection of assets in CityEngine that you can use in rules and call into rules. And that'll be Q4 this year. We'll have the first set, and we'll add models to it, say 400 models a year, 400 to 500 models every year for the next 3 to 5 years, I think. We're also working on a set of rule libraries. So there's the esri.lib that's built in to ESRI. We're also publishing rules on ArcGIS Online and also as part of the Living Atlas. So the Living Atlas rules are curated rules that we've reviewed. There's some that we've created. There's some that partners have created, but we think they're good enough that we want to recommend them for people to use. And so you'll see more and more rules come out as part of this rule library. And it's a good place to start if you're just getting started with CityEngine. So
all right. Yeah, and I wanted to mention, thank you, Eric. We're all down here at the 3D showcase, almost directly beneath us, to the right of the info booth in the Esri showcase. Come down and see us if you guys have any detailed questions. Eric, myself are there. We'll also be there with a lot of the Zurich R&D staff as well to answer any particular question you have on CityEngine. We have a manila folder that went around. If anyone wants a link to the PowerPoint that we've shown, a link to the project files so you can actually build San Diego yourself, we'll be sending that out later as well. Otherwise, if you don't, you can take a picture here, and you can find a lot of the resources are available, as well as a free 60-day trial of CityEngine. So with that, we wanted to open it up for Q&A. I know there's about 5 minutes left, so please, if you have any questions, feel free to raise your hand. We have a great panel, and I just want to thank, for instance, Devin, Eric, for their great work. Thanks. Yes? Right, so CityEngine is licensed much like many of our premium apps. Yes, so it is a desktop app versus a web app, though.
And also, is that doing the same thing as AutoCAD? Can it be replaced by AutoCAD?
No, it's really meant, AutoCAD is really for site detailed design, making construction documents, right? And CityEngine is really for that conceptual urban design capability that would be visualizing an AutoCAD document, for instance. So you can take in AutoCAD files as DXF, the interchange format, and you can start to apply rules, for instance, on your AutoCAD layers. So if you had a layer of parking, a layer of buildings, a layer of trees, such as even the symbolized trees in AutoCAD, you can have a rule for each one of these layers that will just pop it up in 3D fairly easily. Mm-hmm. Yes?
Question about ArcGIS and CityEngine, the relationship between them. Since I get clients, they work VM models, so we have to propose a practical solution path for their BIM model import and editing.
Mm-hmm.
So the BIM part is supported by ArcGIS Pro but partially by CityEngine.
Correct.
So we can import BIM models into ArcGIS Pro, but multi-patch editing was only supported by CityEngine. So I have to import BIM models, then export to CityEngine for working, and then after editing, export to ArcGIS Pro again for further.
So you're going to be editing BIM models?
Yeah.
Is that right? Okay. So
since users want to add BIM models, since they have to do some analysis and get some figures out and try to change their option or proposals immediately and get the results to find better work. So we have to put a...
Sure, absolutely. So it does come into CityEngine as a collada. So the purpose of saying that yes, Pro imports BIM is that when you bring BIM into Pro, it converts it to features within the geodatabase and allows you to have a much larger model because it's not stored in memory, in 3D memory, right? So when it comes to CityEngine, you can bring in a BIM, but usually the shell, right, or an object that you'd want to manipulate. You're not going to be able to run analysis in CityEngine, but you would be able to manipulate it like you would in SketchUp, right? So CityEngine will treat BIM just like SketchUp treats BIM. When it comes into ArcGIS Pro, if you do want to make modifications to it, you do have that option in Pro as well. For instance, maybe using a rule or adding new features onto the BIM model that you can start to actually extrude inside of Pro. So there is the ability to, for instance, run a CityEngine rule on the existing model, which could be the BIM model. And you can do a lot of manipulation that way.
So I don't have to export model, just using different rules to a modification.
Exactly. Yeah, and we'll be downstairs if you want to come by and find someone to talk to at the island as well. Yeah. Yes?
Economic analytics. So what does smart code cost versus our traditional land development cost? They want CityEngine as a great tool to show the form.
Mm-hmm.
What about the function cost? Do you have a partner to tie in with you? Or?
So you're saying, do we have a analytical model behind, for instance, some of our rules? Right. So we don't. Esri doesn't provide a model like Envision Tomorrow or Community Viz. Those are proprietary models. Bergman has a model. I mean, Devin, I'm sure your firm has a model. These are usually proprietary analytical models. And while Esri, I vote that we should get into the game, but we aren't. So what we do have is the ability to write a CityEngine rule for any model. So if you have one that you want to use, then you'll be able to have a rule that matches that model. Yeah. Yes.
We want to model trees and especially tropical trees from Singapore into the CityEngine. So you mentioned that there will be some libraries. Can you explain more onto this? How
Sure. Sure. So we do currently have some vegetation libraries. You'll find that when you first open up CityEngine, there'll be an esri.lib for library. So you'll find a lot of the vegetation rules already there. So you can bring in your points, and you can use plant loader rule, which is a default, one tree per point or polygon. And we also have rules that allow you to bring in entire areas of forest or vegetated areas, right, as polygons. You can apply a rule to that and adjust the density of trees and how they're arranged on that polygon. We support over 100 different species right now in terms of symbology. So there are 100 different models already in there at 3 different resolutions. So you have the very high detailed tree with all the branches and the leaves. But you also have the 2 PNG images, the transparent images, to give you a low resolution tree. And we also have the massing of the tree. So if you bring in, for instance, one of our palms, I think we have maybe 4 or 5 different palm varieties, you can apply it, see it both as the model, but also as the analytical mass of the model as well. That's very useful when you're running, for instance, a shadow or solar analysis, taking into account the trees as a mass unto themselves. So we do support those trees, and the libraries, you'll find them directly in CityEngine as well. And those can be used in Pro as well.
Yeah, and if you have your own tree models for specific tropical varieties, you could actually take that rule, download it, crack it open, and expand it to support the different trees that you have. So you'd basically look at making those PNGs manually yourself, and then look through the rule set, find the analytical trees that are closer. And there's some pretty simple parameters in terms of shape and canopy width and canopy height that you program into. It's a case structure, a pick structure, and then you could just add in your own trees to it and expand the library.
Any other questions? All right. Thank you very much. Thank you.